Okay, for chemistry, your Unit 3 lab is all about heats of reaction. It's looking at the heat exchange when bonds break and when new bonds form, when chemicals react to form new chemicals, how is the heat exchanged, and how can we predict the heat exchange in those reactions. Okay, so the study of energy is called enthalpy. That's a funny word, enthalpy. And it's very important to the study of chemistry, not physics. One of the important things you need to know is the unit calorie. Okay, the calorie is a unit of energy measurement. And 1 calorie is the amount of energy you need to raise the temperature of 1 gram of water by 1 degree Celsius. So for example, if you had 2 grams of water and you wanted to change both of those grams by 1 degree Celsius, you would need 2 calories. Okay? If you had 2 grams of water and you wanted to change the temperature by 2 degrees Celsius, you would need 4 calories, right? So you would multiply them. Every time cells in our bodies use food, the breaking of bonds in the food molecules releases heat energy. Okay? Now, the amount of energy released by food is measured in calories with an uppercase C. You'll notice up here the calories are lowercase c. There is a difference. The uppercase C is actually a kilocalorie or 1,000 calories. Okay, so that means this slice of cake, if the nutritional label says it has 555 uppercase calories, that actually means it has 55,000 lowercase calories in that one slice of cake. Seems like a lot, right? Okay, so how do we look at enthalpy values? Chemical bonds break in a chemical reaction, and energy in the form of heat is either released or absorbed. Okay, so if it's released, we call that an exothermic reaction. If it's absorbed, we call that an endothermic reaction. Those words are here. This energy exchange is called enthalpy, or symbolized as delta H. Okay, so when the delta H is negative, that means your final enthalpy was less than your initial, which means that your reaction released energy or was endothermic. If heat is absorbed and you have an endothermic reaction, I think I just misspoke, that's exothermic. If you have an endothermic reaction, then your delta H is positive. Okay? The practical applications, cold packs, heat packs, those packs get cold because of a reaction in the surroundings. Okay. Calorimetry. So how do you find the amount of energy? You, to find the enthalpy of a reaction, you multiply the mass times the specific heat of water, which is 1 for water, and the temperature change. So the specific heat will be different if you're using joules, as you will see in a moment. So it says in the first part of the lab, you will determine the value for delta H for the reaction of baking soda with vinegar. You will use 4.2 joules per gram degree Celsius as the specific heat of water. So make a note of that so you don't get lost later. In the second part of the lab, you're going to observe the enthalpy of the reaction for the oxidation of iron. It's like how rust forms, okay? And then this talks a little bit about coffee cup calorimetry, but you won't be actually doing the lab, so you're just going to be analyzing the data. Now, this is a really important page. It shows you how to calculate the enthalpy using a new method called Hess's law. Okay, Hess's law is an alternative way to calculate enthalpy reactions. So you'll see you have the reaction of methane plus oxygen. This is like burning methane, gives you carbon dioxide and liquid water. Okay, this reaction actually happens in 2 steps. Because the reaction is burning so hot, the water that's initially produced is a gas. And then as it cools, that gaseous water becomes liquid. Okay, so both of those have some energy, heat energy associated with them. Notice the negative means exothermic. So you take both of those enthalpies, you would add them together, and that's how you would get the enthalpy of the reaction. Okay? All right, so I'm going to help you out with your pre-lab today because it's challenging. All right, so here's your pre-lab. The first question says, suppose you wanted to calculate the heat of reaction in the formation of ammonia gas and gaseous hydrochloric acid from solid ammonium chloride. First thing is write a balanced equation for this reaction. So I have written the balanced equation for you here. The lines are there. But if you actually count the atoms, you'll notice that the reaction is actually balanced already. Okay? So that's your balanced chemical equation. I'm just going to keep going because you can pause the video. All right. Then the second part says the heat of reaction for the process described can be determined by applying Hess's law. And the first question says, which two of these heats of reaction would be the easiest and safest to measure in the lab, and which two are better obtained through reference sources and why? So then it says, consider whether the reaction takes place in an aqueous solution or involves noxious gases. So anyone that is aqueous can easily be replicated in the lab, but if you have noxious gases, then those are better to just get off of a reference table and not run in a lab. Okay, so just keep those in mind when you're choosing. Question C, what is the heat of reaction for the process described? So now you have to actually calculate the enthalpies. So what I've done here is, and you can take a screenshot of this and recreate it yourself, but these are the reactions. These are the reactions that are going to happen. What you're going to do is use the chart at the bottom and fill in the heat of reaction for each of these. Now, here's what you have to keep in mind. If the reaction is going in the other direction, like for example, this one is going in the opposite direction of the one that it gives you in the chart, then you have to flip the sign of the delta H. So instead of it being negative 75, this one would be positive 75.14 kilojoules per mole. Okay, because it's the reverse of what you see here. So you will fill out all of those and calculate the heat of reaction for that process. Okay, and then let's close that. Then you get to your lab itself. Okay, I will reiterate that the introduction has a lot of good information for you. It goes over some of the concepts. It talks about enthalpy. It talks about endothermic and exothermic. Please take the time to read through this material. Photosynthesis is the example they use. It's an endothermic reaction. Sunlight is absorbed. Burning of hydrocarbons like propane and wood and oil, those are exothermic reactions. Okay, they release heat energy. So in this lab, you're looking at the baking soda and vinegar reaction. This is the chemical equation for the baking soda and vinegar reaction. Okay, so this is your baking soda here. This is your baking soda here, sodium bicarbonate, and this is your vinegar. The second reaction you're going to be looking at is iron and vinegar. and to form an iron oxide. There are several oxides, it tells you, and some hydroxides. In this experiment, assume the reaction for rust formation is the following. So make a note of that. That's the reaction you're going to be running in the experiment itself. The procedures you will not need if you're running the dry lab. Okay, so in the dry lab, the numbers are given to you. All you have to do is calculate the change in temperature. Okay, once you calculate the change in temperature, you're going to go ahead and answer the questions. So for this one here, calculate the approximate enthalpy of the reaction in joules. Remember, no, so it's going to be the mass, okay, or milliliters, times the specific heat, which in this case, it gives you the 4.2 joules, okay, and then times the change in temperature. All right, so that's how you're going to do that one. And then you'll decide if it's endo or exothermic. The way you decide that is by looking to see, is it positive or negative? Okay, is it positive or negative? And then number 3, what steps could be taken to improve the accuracy of your results? I don't know why that's here. The accuracy of a larger sample. Okay. I don't know why the answer is already there for you. Okay. Then in step 2, so you have your temperature here. You're going to calculate the temperature change yourself. And then question is, did the temperature go up or down? Is it exo or endothermic? And think of some other chemical reactions that are either exo or endothermic. It gives you one example. It wants you to think of some other ones to do. Okay, so that's your lab. It's pretty simple, but you do have to have an understanding of the enthalpy and endo and exothermic reactions to do this well. Okay, I hope this helps. If you have questions, shoot me an email. I'll be happy to help you.